Well, in this exercise, number 9 from the section, we're going to take this parallelogram and find its area two different ways. We know theorem 11.2, base times height is the area of a parallelogram. And again, we're given this parallelogram. Probably the most straightforward is, let's call DC the base. And since I've got this side is parallel and congruent to this side, either of them honestly could be the base, DC, or AB. And with that, 16 would be the corresponding height. And it would be a simple matter of base times height, 160 square units. Well, that was pretty easy. I think you all got that one. So let's just look at the only slightly less obvious. Let me look at the figure this way. And I'm going to look at this side and this side, the other two sides. And I will label that as the base. Then the perpendicular distance between these two bases would of course be the height, or 8. And it would show up looking a lot like that. Same thing. Now, we're always trained that the base is on the bottom. Doesn't have to be. But if you want to see this a little more plainly, you could take this figure, and you have to do this in your mind. Just rotate that figure over like that. And you can see this is the base, and that is the height. So these two, same answer, same problem. Now in exercise 14 here from our textbook, I'm not going to go over this. This is review from your previous chapter, but you can freeze the frame there if you need to. Simply the Pythagorean theorem, finding the missing side of this triangle. I did draw it to scale for you. And it turns out to be yet another of the Pythagorean triples. Not one of the 4 I had you memorize, because we know there are many Pythagorean triples. So it turns out that we've solved the missing leg was 13. So you can go through that yourself if you need to. But we're moving on. We want to see area and perimeter. And area, just to remind ourselves, base and height are the two legs. Regardless of which one is which, base and height, height and base, we're going to use the two legs of a right triangle. That was the key here. And when I make my substitution, remember it's the 13 and the 84 I'm going to use. And my area will be in square meters. You can write that meters with an exponent or SQM. But either way, you solve for this. Remember, these units are different from the linear units that you're going to find in perimeter. Oops. Because in perimeter, you're simply adding up the 3 numbers. Add the 3 numbers together, and again, because it's a Pythagorean triple, it's going to come up a whole number solution. So your units, square meters and meters, or linear meters. Done. Well, here we're going to solve for the unknown in this figure, which x happens to be the height. We could have called it h, but your textbook called it x. We know the area of the figure, and we know how to find the area of a triangle, and we're given the base. Now, to be clear, the figure could look like this. It might look like this. It could have looked like this. It could have been right. It could have even been obtuse. We remember from our shearing the triangle exercise, these all have the same area. But your textbook made it look something like this. Now let's get on with solving it 2 different ways. If I use the literal equation method, I'm going to take the equation of a triangle. I'm just going to use the symmetric property because I want my variable that I'm solving for, h, to be on the left side. Makes more sense for me that way. I can now double both sides of the equation. Divide both sides of the equation by b. I now have an expression, or I've rearranged this equation in terms of h. Once I do that, it's a simple matter of substitution, and then it's just arithmetic. I've got 76 divided by 12. I've got square inches divided by inches, and regardless, I come up with a height of 6. Now, alternatively, what a lot of you like to do is just use the equation as it's given,
without rearranging it, and you might substitute directly in like this. Now, if you do this method, we might employ something called dimensional analysis, something your chemistry teacher has been talking about. Well, let's simplify from here to here. You can see we've doubled both sides of the equation. I could have really taken half of 12, but this works. This might be a little cleaner, especially when we have an odd number for the base, for example. Now, I'm going to show this division, and again, I said this dimensional analysis like you did in your chemistry days. I do it this way because I can see that the inches divide out inches, inches divide out inches, and what I must be left with, I've got h on the right-hand side, which is my variable, and I have units of inches, and that's what I wanted, was a linear measurement. So I take 72 divided by 12, and again, 6 inches. Either way, it works out fine.
Let's use our algebra skills to solve problem number 19 in our textbook. I've already got a figure drawn here. We've got a triangle where the height is 1/2 of the base. And yes, I drew it in an unconventional way. The base does not have to be on the bottom, but we're always used to seeing, I guess, the figure looking like this. If you're making a sketch, all right, go ahead and make it this way. You've got base and height. We're solving for this. Again, the height is half the base. So let's see what we've got here. We know the formula for the area of the triangle. 1/2 base times height is the area. And in this case, we know that the area is 4 square feet. And it's time to come up with a variable expression to link the base and height. As we said, the height is half the base. But an easier or a better way to represent that, I would think, would be to say that, well, then the base is twice the height. When I'm doing a substitution, I prefer this. It seems a little cleaner and avoids those fractions. Let's make our substitution. So I know 1/2 times 2h times h. We can simplify all that. That's going to all simplify to h squared is 4 feet, or 4 square feet. We're almost done. This one just about solves itself. We take the square root of both sides of the equation, and clearly h is 2 feet. Remember, the square root of square feet is linear feet, or feet. And now we'll just say, I guess the base must be twice that, and that would be 4. It checks out all right, because 1/2 base times height. 2 times 4 is 8. Half of that is 4. And it looks like we got it. Now, you probably could have done this one intuitively, but this would be the methodology that may help you with more, or let's say, more difficult numbers. Well, here's an algebra exercise using a parallelogram. We have a description of a parallelogram here. Exercise number 20. From that description, I can imagine a parallelogram that looks something like this. It's got a height that's 3 times its base. Now, again, I could draw it like this. I could draw it over like this. Doesn't matter, no matter how I visualize it. Height, 3 times the base. So let's put it in the orientation that we see the most common over here. And let's just start doing a little substitution. We already know that the area is 507 square centimeters, and we're going to need to develop a relationship, an expression to make these two one variable. I know the height is 3 times the base. This reads directly from the word problem. I would prefer that. An alternative, I could say that the height is, or the base is 1/3 of the height. Height divided by 3. Honestly, between the two, I'm leaning this way because it seems cleaner and it avoids the unnecessary fractions that I know my students don't like. So I'm going to replace h with 3b, and you can see where this is going. A little bit of algebra. Next thing I'm going to do is multiply this. And I generate a b squared term. And right away now we know what to do. Let's do a division. Divide both sides by 3. And now it looks like we're going to have to take the square root of both sides of the equation. And if I take the square root of both sides, I know the square root of b squared is b. The square root of 169, I recognize that as a perfect square of 13 from that when I made you memorize all those. And the square root of square centimeters is, of course, centimeters. So that's the base. If I triple it, I get the height. And just to double check with your calculator, multiply 13 times 39, and you certainly do come up with 507. And we're done.